Thanks. Buenos dias. I'd just first like to acknowledge my co-author and Jen Jackson and Phil Trasson of BASS, David Wilson and the Cosmos Energy MMO teams, Sandra Clough and EcoAfric for their support. So migratory behavior in the Great Baleen whales has evolved in response to spatially segregated selection pressures. They feed in summer at high latitudes where there are dense concentrations of prey, and most but not all then migrate in the winter to low latitude habitats where they breed but feed little. And I'm going to present two case studies of this behavior. The first being the Southwest Atlantic humpback whales. And this is a population that's recovering from drastic exploitation by 20th century industrial whaling. And tracking studies by Alex Zerbini et al. In Brazil have shown that these whales, which breed in the shallow coastal waters of Brazil, in summer migrate pretty directly, more or less in straight lines, to their summer feeding grounds around the South Sandwich Islands and South Georgia. So we conducted a line transect survey combined with a wide-scale multinational acoustic survey that was designed to estimate the biomass of krill in this region. And from that, we could confirm what the Brazilians have found, that this population has pretty much recovered its numbers to pre-exploitation levels. And I'll show here a couple of plots of just the South Sandwich Islands stratum, where we found that the highest concentration of krill biomass coincided with the highest concentrations of humpback whales. So, the whales knew where to go. And looking at historical whaling data, we found that, surprisingly, humpback whales can restore the weight lost, about 50% of their body mass, in a very short period of time, just 3 or 4 weeks. But this is providing they can find high enough densities of krill, because their lunge feeding behavior has high energetic demands. And there's widespread concern now, of course, about the impacts of climate change, which threatens to change the distribution of krill. And also, since the exploitation days ended, there's now an active commercial krill fishery. And critically, recent studies of humpback whales around the Antarctic Peninsula have demonstrated that pregnancy rates vary with krill abundance. So now I'm going to turn to the other case study, which is of Northeast Atlantic Balanopterid whales, using a data set, a large data set collected as MMOs on seismic surveys in 3 main offshore strata corresponding to Morocco, Western Sahara, and Mauritania, Senegal. It's a very large data set, more than 90,000 kilometers of effort, about 3,000 sightings, of which almost a third were of baleen whales. And it's the study area lies within the Canary Current upwelling ecosystem, which is one of the world's only 4 main eastern boundary upwelling ecosystems. They only occupy about 2% of the global ocean area, but produce about 20% of the fish catch. So they're extremely productive, and they're also highly dynamic. You can see in the animation on the left, that's sea surface gradients or fronts changing from day to day. And if we look at the intensity of the upwelling system, the central plot shows upwellings through 1 year. There are two peaks, one in the summer and one in winter, and the winter peak is the greater of the two. But when we look at what's happening over the last 10 years, the left-hand plot shows the summer peak, and the right one, the winter peak of upwelling intensity. There are certainly changes going on, and it's been predicted, it's been forecasted that upwellings will increase with climate change due to increasing differential between land and sea temperatures, driving ever stronger winds, which drive the upwellings. But to me, it looks like there may be some sort of cyclical event going on that's perhaps reminiscent of the El Nino cycle. So looking at our data set, we can see from monthly sightings rates that the baleen whales are principally winter visitors there. And so we selected just data from December to April for the analysis I'll show you now. And to look at distribution, we used a maximum entropy model with environmental variables applied only to those sightings for which we had a high confidence in species identification. And then to look at abundance, we applied density surface models, but there we took a subset of data from the most reliable observers. And here are the resulting distribution plots. And it's immediately obvious that the blue whales and sei whales are sympatric. They're mainly concentrated off Mauritania and Senegal, whereas fin whales are actually rather thin on the ground down there, and their main area of distribution is off Morocco and Western Sahara. And looking at abundance, we had a difficulty here because a very large proportion of these whales were not identified to species level. So we've estimated the abundance of all baleen whales combined in the Mauritania-Senegal stratum. And if we assume that the species are in the same proportion to those that were actually identified, then we would estimate there were well over 1,000 sei whales present, and the second most abundant species being blue whale, with 60-odd animals. And fin whales and Breeders' whales take up the rear there. Now, there's a lot of evidence for winter feeding these whales. Firstly, direct observation. We saw a lot of cases of sei whales skim feeding at dawn and dusk especially. And Kees Kamphuisen, who's been doing a lot of seabird survey work down there, has frequently found whales associating with aggregations of feeding seabirds. And of course, it's the fact that they're in that highly productive area anyway. And finally, Monica Silva and her group in the Azores have found evidence from stable isotope studies that baleen whales migrating through there have been feeding in Northwest Africa. So this variation from the feasting-fasting paradigm, we should ask, to what extent this has always been the case, or is it possibly a response to changes in Arctic ecosystems caused by climate change? And does it matter? Well, to answer that last question, we need to look briefly at the physiology of feeding and breeding. And in mammals, thanks. In mammals, there are two key hormones that drive feeding behavior. Ghrelin, the hunger hormone that's secreted by epithelial cells in the stomach, and leptin, the so-called satiety hormone, which is secreted by adipocytes, by blubber cells in whales. And leptin's a very interesting hormone because it's a multifunction hormone. And there are two areas of the hypothalamus that are sensitive to, that have receptors to leptin. One signals the central nervous system about levels of energy stores, and so suppresses feeding behavior. But the other regulates the production of sex hormones in both males and females. So it regulates the secretion of hormones like follicle-stimulating hormone, luteinizing hormone, And it also plays critical roles in pregnancy and the maintenance of lactation. So it's critical for breeding. So what conclusions do we draw from all this? Well, firstly, if whales arrive hungry in their winter habitat, their reproductive potential may be compromised. Clearly, measuring hormone levels can provide indices of metabolic condition, reproductive status, and fitness to breed. And so I would suggest that monitoring leptin levels in whales on migration in winter could help us understand how populations are responding to climate change and other anthropogenic impacts. And finally, the conservation of migratory whales needs a global dimension. Brazil's humpback whales depend on good management of the Southern Ocean krill fishery. And the North Atlantic Balanopterid whales depend on effective management of anthropogenic threats in Northwest African offshore ecosystems, including fisheries and hydrocarbon extraction. The seismic surveys on which these data were based resulted in finding Africa's largest offshore gas field, which is currently being developed by BP. Thank you.